Hello and welcome. In this particular section, we will look at Reactive Java. In order to look at Reactive Java, we will be looking at reactive manifestos and reactive programming paradigm. Reactive is not new to the software engineering, but within few years we have seen increase in reactive solution at large scale. Let us look what reactive programming actually means. Reactive programming is a paradigm which enables programs for a stream of data in non-blocking, that is asynchronous manner. It makes solutions such that the system reacts to the stream of events. Reactive programming paradigm is similar on the principle of observable and observer pattern. Observable being the emitter of events and observer observing the emitted events with the knowledge of steps to be taken with incoming data. In real-world example, let us consider a newspaper or a Netflix show. Here, the newspaper or the Netflix show is what you have subscribed to, so it is observable. It emits streams of events in form of news or show content. In order to receive newspaper every day or news shows from Netflix, the first step is to subscribe. Once subscribed, whenever the observer emits events, that is, a newspaper publishing the new news daily or an episode on Netflix, you receive it. On every new event published from publisher, that is the news daily or the news or new Netflix show, you are free to act upon as an observer. In case your subscription is expired, which you can think as an exception, you should be taking action based on your interest. Once Netflix show is finished or you have read the newspaper and no longer wants it, it can be a notification of events being completed or you want to unsubscribe. Similarly, in software world, we can program based on events to make more robust solution which can scale better. The evolution of computer has been focused on processing speed. As we increase the number of the cores, we can work on multiple processes together. We have added more cores, but if we keep our programming model as single-threaded application, we will never be utilizing the processor to its full capacity. When the load grows up, we will be scaling by adding more CPUs, yet all the CPUs will be fractionally utilized. This will increase cost while we can have coded much more effectively utilizing all the available cores. We could have saved a lot of money quite easily. There is one more thing that we should look on. Consider that there is an order from a normal e-commerce website where we need to call different services like cart service, user service, and product services. We aggregate all these three calls and send back the response to the user. The throughput of such a call will be the time taken by the cart service, say X, product services, say Y, and the user services, say Z, along with the time taken in the network calls. So the throughput of such call will be the time taken by cart service, that is X, product services, that is Y, and user services, that is Z, along with the time taken in the network call. So the total time taken will be the network time plus X plus Y plus Z. If we execute these network calls in parallel, and when all the calls return the responses, we aggregate their response and send the aggregated response, we can save time. In this case, the time taken will be total time taken should be network time plus max of X, Y, and Z. So if we execute in parallel and aggregate all those responses, we can save time. This will save our time and responses could be much faster. We can achieve it by already present, future, and callbacks. Then why do we need to look at reactive paradigm? With increase in network calls and callback function, Slowly, it will lead to a complex structure and it will become a callback hell. Reactive paradigm works on all these functionality and yet keeps the thing simple. We will explore it in this series on reactive programming with Java. In next section, we will look at the founding principles of reactive programming, which is Reactive Manifesto.